Hi, Assalamualaikum. My name is Syahzani Arifah Binti Hasan. I will be presenting my final year project 2, which is radio frequency identification RFID based cable detection system. In this video, I will briefly discuss about the concept of cable identification and how the system can help in reducing the casualties due to cable theft issue. Moreover, the methodology used in developing the system as well as the result and analysis will also be addressed. Finally, the conclusion of this project and the future work recommendation will be explained. As we know, cable theft have given the impact of high numbers of accident statistics due to the power outages and cable exposure that can cause kill or injure. Therefore, in this project, the cable identification is proposed that uses the radio frequency identification RFID-based technology. Onto the concept of cable identification. So, cable identification refers to the wire or cable that have marked or label to distinguish which cable which is belong to. In other words, the identified cable has its ID number or tag to ease the process of tracking or collecting information. The use of cable identification is to show the cable's detail when there is the occurrence of cable theft. Why RFID? Before, the usage of physical tag and connector to create the tag identity to the cable is practically inefficient. Besides, alarm system, RFID technology can act accordingly to detect and monitor by attaching the RFID tag to the cable and the reader will scan and read the data via radio frequency wave transmission. Moreover, RFID is a cost-effective and more secure compared to the conventional physical tag. The objectives of this project is to develop the cable identification system using RFID technology and Arduino controller approaches, and as well as to observe the behavior of RFID system for the specific parameters, which are voltage and distance between tag and reader. The scope of work divided into three main phases, which are modeling and design phase, technique and algorithm, and as well as prototype and development phase. In modeling and design phase, Arduino controller, RFID reader, OLED display, and RFID tag is used. Although Arduino uses the coding to work, the component itself is very expensive depending on the usage. Next, the RFID system has variety of type that offer different detection range based on its frequency. For example, in high frequency RFID system, the range detection can reach up to 1 meter given that the frequency is 13.56 MHz. Apart from that, the application also vary accordingly. Then we have the technique and algorithm phase. The algorithm used is Arduino IDE software. A command for cable detection system will be created in Arduino IDE before uploading to the board. Lastly, after creating the coding, the prototype will be developed in which Arduino Uno will be used as a microcontroller, RC522 RFID as RFID reader, ISO 14443A as RFID tag, and OLED display as a display. Then, after developing the prototype, the testing will be done to obtain the desired result. The methodology involved in achieving these objectives are by combining both software and hardware. With that being said, the simulation using Proteus and hardware components such as RFID RC522 and Arduino Uno are used. The circuitry connection for this project is shown in the slide. How this system works. Apparently, the RFID reader will scan the RFID tag and send the data received to the Arduino Uno for processing. Upon receiving, the Arduino will process the prompted codes as per desire by the user. Then, the output is displayed on the OLED display OLED as well as the virtual terminal in the Proteus software. Since the RFID tagging system is implemented on TNB cable, which is for utility pole to pole, the installation cost and profit gain ROI needs to be considered. ROI, return on investment, is a measure to calculate the profit gain from an investment. The cost to develop this system is approximately RM88. Thus, the ROI is the ratio of net profit to the cost of investment, which makes the profit is roughly 41%. The installation of the system is estimated 35 meters apart between each pole. 3 RFID tags will be placed within the cable for every 11 meters. Say that the selling price for this system is RM125 with RM2.50 per unit tag, then the total installation will cost about RM232.50. This is the prototype. This is the front view of the prototype, isometric view of the prototype, and as well as the plan view of the prototype. Next, I will be explaining the characterization of the system. In this project, the analysis that has been done are range analysis as well as voltage reading tests. Both tests were conducted with or without obstacle in between the reader and tag horizontally and vertically. From RFID range analysis, we can summarize that regardless the position of the system, the reading range is influenced by the obstacle itself. This is due to the value of material properties of the obstacle. As for the voltage reading test, the nearer the distance between reader and tag, the greater the voltage received by the reader either in horizontal or vertical position. So we have come to the end of the video. As conclusion, all of the objectives has successfully achieved. Different type of RFID system will offers different detection range. Additionally, the voltage received by the reader is always affected by the distance between RFID reader and tag as well as the material properties of the obstacle. In future works, I would recommend to design an RFID tagging system where the detection range can reach up to 1 meter or more, as well as the abilities to read all type of RFID tag. Lastly, the future researcher can use the high input voltage to boost the RFID detection system. With that, thank you and have a good day. Assalamualaikum.